Hello students, I've had some issues here the last couple days trying to get this answer key ready for you. Hopefully this is something that is working and I'm not just spinning my wheels like I have been the last 2 days. So when I recorded your answer key to that first assignment that I posted, I was going through and doing the problems and recording as I was going through. Well, now I have the book and I have all the problems with the answers here. So what I'm going to try to do is I'm just going to try to explain what I did in order to get those answers. So we're going to start with number 1. And I found the answer to be A. And essentially what I did was I just went through and I just tried numbers. So I knew that a restaurant gift card was $50. So if I buy 5 restaurant gift cards, that would be $250. And let's see, $20 for each movie theater gift card. And I took the 10 times the 20 and got 200. 250 plus 200 equal 450. So that was basically how I answered that, which is nice about multiple choice from time to time. So number 2, what I did was we talked about, this is asking about what's the meaning of the y-intercept, and the y-intercept being this point 32, and it's where it starts at. But what that means is that it's 32 degrees Fahrenheit when it's 0 degrees Celsius. So the answer to this ended up being C. Okay. Moving on to number 3. The problem with number 3 is we have not talked about this idea of scientific notation. So what I'm going to do is I'm going to insert a video for you guys to watch involving what scientific notation is. The gist is 10 to the 5th power this is really 6 times a 10 with 5 zeros after. So it's really 6 times 10,000, which is 60,000. So what I did was I took and I went 6 times, and I know I have this calculator, and I know it's not beneficial, it's not the same as yours, but you can do very similar things. So what I did was, I did 6 times 10 to the 5th power times 15, and I got this 9, looks like 9 million. So then what it is you count the zeros after the 9, you count the places, and there were 6 zeros after the 9, that's how I ended up with that. I'm going to actually insert a video for you guys to do, and I'll announce it on Schoology when I do for you guys to go and figure out what scientific notation is all about, because it is one thing we haven't done yet this year. So, all right, moving on to number 4. It's been a while since we've done transformations. It says which sequence could be used to transform P to Q. Okay, so what it looks like, what happened is it looks like it flipped, which means it was a reflection somewhere. It either flipped down, but if you flipped it down, it would have ended up looking like this. So it didn't flip down, it flipped over. So that's a reflection in the y-axis. And then when you put this here, so it'll be here, 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 and here, what happened was it was then slid down to here, which is what choice C came out to be. Okay. For number 5, what you basically are doing is match the graph to the equations. So what I did was I started with this y equals mx plus b format that we've referred to quite a few times throughout the course of the year. And I started off at 10. This one started at 10, which means that the y-intercept was 10, the b. And then it goes down at a rate of down 2 to the right 1, which is the slope, negative 2 over 1, which is just negative 2. Then I looked at this line, it started at 0. So you can put a 0 there, or you don't even have to have it there. And this one goes down 1 to the right 2, and that's the slope, down 1, right 2. So then I just found the answer that had those 2 equations attached. All right, so that was answer B. Moving on to number 6. Okay, for this one, what you have to refer to is the reference sheet. Okay, so what might benefit you is taking the reference sheet off the front page, ripping it out, and then refer to it when you need it. So when you look at the reference sheet, you have, this refers to a cone versus a cylinder. So here is the formula for a cylinder, the volume. I wrote that formula down. And then the cone is 1/3, the same formula, but 1/3 of it. So that's how I came up with the ratio of 1 to 3, because of this 1/3, the difference in the 2 formulas. Number 7 is which is a linear. This has r squared, this has r to the 3rd, so r to the 1st power. That's how you know something's linear, so equation 1 is the only solution. Okay. All right, number 8, we have a scatter plot. And if you look at all the dots, it looks like they're scattered all over the place, so I determined that there was no association, because it doesn't really look like it's going up, it doesn't look like it's going down, and it definitely doesn't look like it's linear. So I just said no association, meaning that there's no connection between the points allowed versus points scored. All right, number 9. Right? And you're going to recognize some of these problems as we are working through them. But in number 9, what we got is Kofi can be represented by 15.55x, which is this line right here. So what you're looking for is you're looking for Bella to be greater than that 15.55, and you're looking for Elsie to be less than the 15.55, which is how I came up with Bella being 15.85, which is just above 15.55, and Elsie to be 15.15, which is just a little bit below 15.55. All right, so that's how I determined the answer to that. Okay. Moving on, number 10, another problem that should look somewhat familiar. Which one is linear? Has to have the same rate of change. The change in y has to match the change in x. It has to be the same across the board. So here what I did was, it went up 1 for 1. So 1 over 1 is 1. And then it goes up 15 for 3. And 15 over 3 is not the same as 1 over 1. Okay? So then I went over to C, right next door. And I said, all right, this is going up 2 for 1. Then it goes up 6 for 3. Then it goes up 10 for 5. And if you look at each one of those closely, 2 over 1 is the same as 6 over 3, which is the same as 10 over 5. So that's how I knew that was the answer. And then I went through the rest of them and said, this goes up 2 for 1, and it goes up 6 for 3, but then it goes up 11 for 5. And 11 for 5 is not the same as these two. And then D, you're going 2 for 1, then you're going 2 for 3, then you're going 2 for 5. All right, so that's how you determine if a function is linear. Okay, number 11. I just used the rules. This is the last thing that we actually talked about before we ended up closing school. But the rule is that when you multiply, you add the exponents together. So I did 5 to the negative 8 plus 4, which is 5 to the negative 4. And then one of the things we talked about was how the negative exponent just means the location, which means that it's 1 over 5 to the 4th. It just means that there are 5 4s, and because it's negative, it means it's below at the bottom. All right? And then number 12, a problem that we've seen since the beginning of the year. It's just solving a multi-step equation. So the first thing you can see I did is I distributed. Here, be careful. Remember what happens when we distribute a negative. Number one mistake in middle to high school math. So this became negative 4t, and then a negative 2 times the positive 3, which is a negative 6. Okay, then I combined, so I did my negative 4t underneath my 3t, and I put the negative 6 under the 12. Ended up with negative t plus 6 is equal to negative 4. I then subtracted 6 from both sides, and I got negative t is equal to negative 10. And what the last thing to do is divide by negative 1. And when you do that, a negative divided by a negative is a positive, which is how I got the answer of positive 10. All right, so I hope that this works. I'm going to try to get it uploaded as soon as I possibly can. And if I don't, then obviously you're not hearing me talk right now. But this is Mr. Sims signing off.